Math 3, Unit 1, Semester Final Review. Okay, so in Unit 1, we did a whole bunch of graphing, okay, and transforming and all that kind of stuff. So when you see linear, what type of graph will that end up making? A line. Good. And so if we graph kind of our basic line, okay, each of these kind of still has like your original point, which is like your vertex. And so since there's nothing with the x and nothing being added at the end, your initial point is 0, 0. And then what would be your slope on this one? 1 over 1. And so we can go positive 1, or negative 1, and draw our line. Some of the key ideas for this one is basically, you know, that our vertex would be at 0, 0. Even though it's not a vertex, we can kind of think of it as a vertex because each of these are in vertex form. And then also that you have your slope, which is like our 1 over 1 in this case. Speaking when it comes to like your generic equation, again here you would have your vertex, which would be h comma k, and then you have your slope, which is your m. You want to grab those papers right there. And basically you need to have 2 points in order to draw a line. So I'm just going to put need 2 points. Okay, so based on that information, we're going to go ahead and graph this line over here. And so we're going to call it our vertex, even though it's not really a vertex, but it's a point on our graph. What would that be? Good. Negative 1, 3. Because whatever's in parentheses, we always set that equal to 0 and you get the opposite. And then this is our number at the end. And then on this one, what is my slope?
Negative 1, 2.
Good. And so if we go ahead and graph this, we would go negative 1 up 1, 2, 3 and make a point. And then from this point, you use your slope. So that would be negative 1 and then write 1, 2. And now that I have 2 points, I can draw my line. Okay. Any questions on linear? Okay, so absolute value. Do you guys remember what that graph kind of looks like? It's a V. Good. So I'm just going to put a V here just to remind us. And so with this basic equation here, again, my vertex for this one would be at 0, 0 because there's nothing with the x and nothing with the y. And then what is the slope on this one?
1.
Good. 1. And so remember with slope, you go up 1, right 1, and then you also go up 1, left 1. So your slope is actually giving you 2 points. Because an absolute value graph is actually a line, but what happens is because it's absolute value, you end up with the V. So half the line is going one direction and the other half flips up to stay positive. Okay? Right? Because if I plug 1 in here, the absolute value of 1 is 1. If I plug in negative 1, the absolute value is also 1. And so that's how you end up getting those 2 points. And so this makes a V graph. And if I'm explaining anything and you're like, I don't get it, please stop me, okay? Because I will go back and try to re-explain anything. So if we're looking at our generic equation here, again, my vertex is h comma k, and m is my slope. Okay, and this one you really need 3 points to graph. But once you have your vertex, you just use your slope going both directions, right? Okay, so I'm going to give you a minute to go ahead and try to graph this one right here on your own. So you're going to start with finding your vertex and then using your slope to make your additional points. Exactly. Yep. Okay, so remember it's not a line. So remember that absolute value is going to make a V. And so remember, so you have your, here we are. So you have your 2, 3. And so you use your slope from here. Yeah. So from this point, it's going to make it 1 over 2. So from here you go down 1, right 2, and down 1, left 2. Okay, so on this one, our vertex, okay, and the absolute value acts as parentheses, and so my x value of the vertex is 2 and my y value is 3, and then we know that our slope is negative 1 over 2. So we always start by plotting that vertex point. So we go right 2, up 1, 2, 3, make a point. Okay, from there we use our slope, and since we're making a V, we're going to go negative 1, right 2, and negative 1, left 2. And so from here, go down 1 and right 1, 2, and down 1 and left 1, 2. And so that is your absolute value graph. Okay, any questions there? Okay, so moving on to the next one, we have our quadratic or parabola. What does the graph look like there? Good, it's a U shape, right? And so if we're graphing our basically kind of generic equation, the vertex on this one would be at what? Good. Vertex is at 0, 0. Okay, and then from there you need your another point. It's important to remember, actually, and on absolute value it's the same too, that these are symmetric or symmetrical. I don't know if I spelled that right. But. Also, A gives you your direction, meaning like up or down, right? So if your A value is positive, it's curving up. If your A value is negative, it is going down. And so what you can do oftentimes with parabolas is just plug in a value, like let's say if I plug in 1 for x. Well, what is 1 squared? 1. And so that means that there is a value at 1, 1. And then since it's symmetrical, there's also one at negative 1, 1. And then we can draw our curve. So if I were to put the value, if I just chose 1 for x, okay? And so all we would do is go y equals, I'm plugging in 1 for x, and 1 squared is 1. So that means y equals 1. So I have an ordered pair of 1, 1, because 1 was my x, and then when I solved it, I got the answer of 1 for the y. you could do the same thing too, where I plug in -1, and when you square -1, it becomes a +1. And so that's how I have -1, +1, or knowing that they're symmetrical, you would get that same answer. Okay. All right, and again, same thing on this one. This vertex again would also be H, K. On this one over here, my A value was 1 and it was positive, which is how I knew that the curve was going up. Also, by plugging in values, it also, as long as you do the correct math, you're going to get the correct curve or direction. Okay? So let me give you a minute here to try to graph this one here on your own. So I kind of choose like either one to the right or one to the left at that point. So starting on this one, what would be my vertex? Good. So 3, -1. One thing to think about on your final is that it is multiple choice, the whole thing. So that's one positive. And so oftentimes, like, you can get your vertex and then go through and, like, know that certain answers can be eliminated, right? We also know that my curve should be going up, okay? And so, but from there, just to be sure that we're accurate, I would go at least either 1 point to the right of this point or 1 point to the left of my vertex in order to figure out my second point. So if I choose 1 to my right, okay, what x value is that? 4. So if I go y equals 2 times 4 minus 3 squared minus 1, what's 4 minus 3? 1, and 1 squared gives me 1, and then 2 times 1 is 2 minus 1, which equals 1. So I have an order pair at 4, 1. So write 1, 2, 3, 4, up 1. Which means that there's going to be a point at what? 2, 1 as well. And again, if you plugged in 2 minus 3 gives me a -1, and when you square -1, it becomes a +1, and so you still end up with that same answer. Yes?
Why did you put in 4 for the x?
So I wanted to pick a point to the right of my vertex.
Oh, okay.
So since my vertex was at 3, -1, I chose 4. Okay, and basically for this one too, you need 3 points in order to graph it. But once you figure out 1, you know it's symmetrical, so the other one's at the same point on the other side of the vertex. Okay, questions on that one? Okay, we're good? All right, so next we have our exponential graph. So do you guys remember what these graphs look like? Yeah, I was thinking L, but you could think of it as a J or an L, but it kind of either goes like this or this, right, for your exponential. So this one you need, there's a few things, okay? One thing is that you have a horizontal asymptote, okay? And your horizontal asymptote is always at your K value. So on this one, there is nothing being added at the end. And so therefore there's a horizontal asymptote at y equals 0. So that's, remember, where we make this dotted line and our graph gets really close to that value, but it never actually equals that value. Okay, we also talked about on this one that it's kind of easier to plug in values and solve. Okay, so basically if this one is 1, if I put anything to the 0 power, if x equals 0, okay, so this a can be any number. So we're just gonna say it's 1, okay, or 2 or whatever. We'll say it's 2, it can't be 1. Okay, so 2 to the 0 power is 1. And so if we were to make a t-chart, if x was 0, we end up getting 1 for y. So there's a point at 0, 1. Okay, and again, we're going to say that a is 2, so 2 to the x power. So if I plugged in 1 for x, we end up getting 2, right? 2 to the first is 2. So there's a point at right 1 up, 2. And so we can end up drawing our graph that looks like this. So basically for every equation, unless it's shifting, there's a point at 0, 1. Okay, and so again, we need to find 2 points. You want to just plug in values for x in order to find your points, and that you have a horizontal asymptote at your k value. And notice that your k value is the part that's being added at the end. Okay, so if we go over here to this example, where is the horizontal asymptote at? Good. So there's a horizontal asymptote at y equals 0. Because if you notice, nothing is being added at the end. Okay? So we would have, you know, this dotted line for a horizontal asymptote at 0. Okay, now there's 2 ways of thinking about this one. We can just plug in values, okay? Or you can think of this, do you guys remember our shifting? And that since you have x minus 3 there, your value that, you know how you had your point that was at 0, 1, which way would that end up shifting? To the right 3. So remember, whatever is with the x ends up being the opposite. And so we should end up having a point that is at 3, 1, because it would shift right 3. Oops, you can't see what I'm doing. So if I were to plug in 3 for x, if you think about this, 3 minus 3 is what? 0, and anything to the 0 power equals 1. And so it would make sense that when I plug in 3 for x, I get 1 for y. Okay, and then in order to graph, we need at least 1 more point. And so what would be a good value, do you think, to plug in for this? 4. Okay, and you could use anything, but 4 is great. So 4 minus 3 is 1, and then 2 to the first power is 2. And so we have a point at 4, 2, and then we just draw our L-shaped graph. Okay, questions? Okay, we're good there? All right, so moving to the other side. We just kind of briefly talked about this, but transformations. So remember when you have a negative in front, that means it's reflecting across the x-axis. If you have a negative with the x inside there, that's reflecting along the y-axis. When you have the x plus a value, remember that's going to be shifting horizontally. So if it's a plus value, it's actually shifting left, and if it's a minus value, it's shifting to the right, because remember what's in parentheses, we always do the opposite. Okay? And then this is shifting vertically. And since it's not in the parentheses, it's either plus is going up and minus is going down. Okay? And so I don't know if you need to make any notes there. So these, we just want to write in words what is happening. Okay? So you can think about this a couple ways, but this original vertex for this first one is at what? This first equation, f of x. 0, 0. Okay? This vertex now is at what? -2, -1. So you could plot both those vertexes and make a little graph if you want to. But if you're starting at 0, 0, and then you're getting to -2, -1, what would you be doing for that transformation? So you would be, I'm just going to write, this graph shifts left 2, because we have the -2, and then it's also going which way? Down 1. Okay, so this one, I want you to kind of write. So look at here. So this one, we're starting at like a 0, 0, okay? And then this one, what is happening? So they're doing a negative inside the parentheses, and then they're adding 3. So how is that one transforming? Talk in your groups for a minute. See what you guys think. So in your groups, see what you guys think. Okay, so what do you guys think? What does this mean right here? When you have the negative inside the parenthesis. So you would do that first. So we're going to put reflects across the y-axis. And then what does this mean here at the end? Very good. That's it. So, and shifts up 3. Okay, do we have questions on that? Okay, do you guys yes, sorry.
So then if you have a negative like outside of the parentheses, then it's reflecting over the x-axis, right?
Yes. And it wouldn't be like outside of the parenthesis, it would be outside of the f of x, like that.
Okay.
But yes. Anybody else, any other questions? Okay, do you guys remember what to do on this? Like, how do you know which equation to plug like one in? Do I plug it into the first one or the second one or both? Do you guys remember? Okay, talk in your groups. What do you guys think? Pay attention to what is after each of the equations. Do you guys see there how it's telling you x is something? What is that meaning? So they're saying that you're going to use this equation when x is less than or equal to 1. And you're going to use this equation when x is greater than 1. So when you have, this is saying that x is 1. So which equation am I going to use? The top or the bottom? The top, because this one has the equals 1 in it, right? And so all we do is take this 1 and plug it to this equation. So we get 3 to the first power, which equals 3. That's it. Okay, f of 0. Would you use the first equation or the second equation for 0? How come?
It's less than or
Good, it's less than or equal to 1. So we get 3 to the 0 power, and anything to the 0 power always equals 1. Okay, and the last one, 2. The bottom equation. So we have negative 2 parenthesis 2 to the second power plus 1. When you're solving this, what do you always do? Parentheses and exponents. And so here 2 to the second power actually makes 4. So then I have negative 2 times 4, which is, and negative 8 plus 1 equals negative 7. Okay. Any questions? All right. This next part, it says to describe the graph of each of the transformations. And so I just want you to state, what does it mean? What are you going to do with this graph if it has f of x plus 2? What will you do? When you have it in the parentheses, what does that mean you do?
shift to the left 2.
That's it. So we would just write shifts left 2. So you can kind of visually think about this one. If this were like on your test, you know that this point would go left 2. And so that point now would be at negative 2, positive 2, right? And you could go to this graph and shift all of these things left 2. So you're going to have the same curve and everything. It's just going to be shifted left 2. Okay, what's going to happen on B? Good, reflect across the x-axis. So what happens is like this point, that's 2 away from the x-axis, and then you'd go 2 down and make a point, right? And so this one is at negative 1, 1, and then you'd have a point there. And so you'd see that this curve ends up, it'll be like a straight line with a curve like that, reflecting across the x-axis. Okay, what happens on C?
Reflects across the y-axis.
Very good. Reflect over the y-axis. And so this one, we'd take that graph and it would like flip over to that side, right? Over the y. And the last one, what happens?
Shifts right 1, down 3.
Good. Shifts right 1 and down 3. Okay, do we have questions on this one? Is this coming back to everybody? Yes? We're good? Okay, last part. So we're going to be using this graph right here to answer these questions. Okay, and so these actually are endpoints. So if you want to add the points in there, you can or should. There's also like a point right here. So it says, what type of function is graphed on the open interval negative 8 to negative 2? And so I'm just going to kind of draw a line to separate this. So what type of function is negative 8 to negative 2? Talk in your groups. So we just talked about. How do you guys know? Yeah, so it's absolute value, and you can see that it's making a V, right? And so these are symmetrical each way. You have a V line. right? So yes, this is an absolute value function. Okay, and so now they have from -2 to +2.
Parabola.
Very good. So we can call that a quadratic function or a parabola. Okay, and then the last thing they want us to do is to write a piecewise function for the graph above. So we need to write these equations. Okay? So, this is how we do it. F of x equals, and remember we kind of have like a little bracket where we're going to write our multiple equations. So let's start, because we always want to kind of go left to right, like reading a book. And so our first equation is going to be absolute value. Do you guys agree? Okay. So what is the vertex? What is this point here on that absolute value? It's at -1, 2, 3, 4, -4, -1. Do we all agree with that? And so we know we're going to use absolute value, right? And so what's going to go inside with the absolute value?
X plus 4.
Good. X plus 4. And then what's going to be added at the end? -1. Now the A value, you need to think about with absolute values, we can see that it's going up 1, right 1, and up 1, left 1. And since it's going up, we know it's a +1 in front. So do I need to write a +1? No. Okay, but we do have to say, because it's this graph, for which part? What X has to be what? Good, less than -2. Works. It could also be less than or equal to -2, but remember the other one will have to have the equal sign. Whichever one doesn't have it, the other one has it. Okay? All right, so then we have the second piece right here, which we said is a parabola. We need to know what the vertex is there. So what is the vertex? Good. -1, 2. So when we're writing that, what will I write in the parentheses?
X plus 1.
Good. X plus 1 squared. Good. And then what goes at the end?
Plus 2.
Good. Plus 2. Now, this parabola, is it curving up or down?
Down.
Down. So that means we know we're going to need a negative in front. We can solve for our A value by choosing a point that's not the vertex. So if you see right here, see how there's a point right here at 0, 1? So if I use this equation, we're going to put our A value in front, okay? And so I'm going to use this point, 0, 1, in order to find my A value. And so we would have y equals A parenthesis x plus 1 squared plus 2. And so if this is my x and y, am I going too fast? We would plug in these values. So I'd end up going 1 equals A times 0 plus 1 squared plus 2. And 0 plus 1 is 1. And 1 squared is 1. So I end up with 1 equals 1A, or just A, plus 2. And then in order to get A by itself, I subtract 2. And so we end up getting -1 equals A. And so that means that we can write a -1 or just a negative out in front there. Remember that your final is multiple choice. Sometimes you'll just need to know if there should be a negative in front or a positive. But I just wanted to remind you how to find the A value in case you needed to find it. Okay? And then what will have to be here? X is greater than or equal to -2. That is correct. And actually, based on that information, because we're saying less than or equal to or greater than or equal to, maybe we should go ahead and just change these 2 arrows. Otherwise, it would be exact endpoints. Like if we had this was -8, it would have been -8 with the parenthesis or the bracket to the -2. Does that make sense? But we'll just change it to this with the arrows. All right. Any questions here? Let me put that back up.